Yeah, well, a little early, but just setting up. So we'll do some Python and Pandas today. Been a long week already. Hello, one viewer. So yeah, today we'll do some Python. We'll play around with getting stuff out of a database and some pricing and some some basic Pandas data frame stuff as we go. I guess I should get some music or something on this. All right, let's see what we can do. Okay, so what we're going to do is we're going to do some basic Python for um, uh, what you would use in FP&A. So we're going to do pricing analysis. I created a kind of a database of purchasing of purchase orders, and I also have a pricing table. And what we'll do is we'll bounce one up against another using Python and Pandas here. So we'll see what happens when we go. All right, so let's do the first thing here. So we have to set up, what we have to do is when you have Pandas, when you have Python, is import the packages you're going to use. So the first thing we're going to import is we're going to import Pandas as PD. So what we're doing here is importing a package and we're giving it an alias PD so that when we code, we don't have to write out Pandas every time. So Pandas again is the Excel of Python. It's the basic data analysis package for manipulating data. Um, there's also NumPy for French, so there's a lot of different ones, but for our for most things, Pandas is good. So we also want to connect to the database that we've made. So I'm going to do import, and I've used an SQLite database as S3. So SQLite is native to Python, so it's easy to work with. If you have other DBs like MySQL or all the other flavors, DB2 databases out there, Teradata's, anything you need, you can connect with a package. Now, there's PyODBC, so if you can ODBC directly into it. There's SQL Alchemy, which is kind of a agnostic engine to connect to databases. But in this case, we're going to do something simple, an SQLite database. So I'm going to cheat a little bit. I'm going to look at the database that we have. So I'm going to look it up right now. And let's see. So I'm going to open up the database that I created. And this is what it looks like. So what you're looking at now is called database browser or DB browser for SQLite. It's a specific thing for SQLite databases. But let's take a look at the database before we get into it. So the structure, there's two tables in this. We have a pricing table and we have a purchase orders table. So if we browse data, here's the pricing table. So it gives us the commodity, a commodity description, unit of measure, user price, and the price date, the date that the price was effective. And here we have purchase orders. Purchase orders have commodity, commodity description, extended description, quantity, unit of measure, all these things you'd normally see in a purchase order um, record database. Now, I grabbed this from a historical database of payments by the city of Austin, Texas. So I thought this was good because it's nice and the data is nice and dirty. So we might have some difficulties that we'd have to work through. So for SQLite, let's do the first thing. Let's go and basically say we need to. All right, so let's check out the database. So first we have to connect to it. So we're going to make a connection. I abbreviate it as con, and we're going to go S3. So we're pulling something from S3 and then connect. So we're going to make a connection. And in this case, I'm going to use a raw string because I'm just going to take this and I'm going to go properties. I'm going to grab the file path in this case. But when you usually connect, it's either an IP address or a host name address to what you want to get, and then you have your authorization scripts and stuff. But in this case, we're just going to connect to this database. But again, this is how it's done. You make a connection, an object, by doing s3.connect. S3, so con. All right, so we have a connection to this database. So let's say we didn't have our cheat browser here at all, and we wanted to look at the tables in here. So a connection to a database, I'm going to go through a simple, because this is actually very generic. No matter what you use as your connection, in this case we're using S3 Lite, or you could use SQL Alchemy or PyODBC. Oftentimes it comes with cursors, so you can query directly into the database using a cursor. So I'm going to make a cursor, which is a C, which is short for cursor. And usually the connection object has a cursor function. So the cursor function creates a cursor that we can use and use SQL commands back and forth to the database. So we're going to do C dot, in this case, we want to execute. So what we want to do is we want to find out the tables that are in this database. Even though we already knew that because we cheated using the DB browser, but if you've got a big database that doesn't have a nice little easy application like that, let's do some SQL. So we're going to do execute. So we're telling the cursor to execute command, and so we're going to do some SQL here. We're going to select the name from SQLite master. So this is the master table within SQLite. All databases have a table master or a view master that you can query, so you can get it in. You have to know, again, the flavor of database that you're working with, but it'll take this command. And basic SQL, you're selecting, that means you're asking for data, and you're asking from a specific field, so you're asking for the name column from SQLite master. So let's see, execute. So it's now executed. Now for this, I'm going to do fetch all, which will fetch what we just executed. So we have two tables in here, purchase orders and pricing table. Same thing. So we get the same data that we had here, the pricing and purchase order data. So that's easy. And that's pretty much it for connecting, the generalized version of connecting to a database. No matter what you use, SQLite, PyODBC, again, you'll make a connection and then you'll use a cursor to execute against that connection. Now, some of these may change depending on your connection, but that's the pretty standard version of it. So, but we can also use Pandas directly. So let's say I wanted to do a query object. We can make an object in Python, and we'll do it select name from SQLite master. So now we have a query. So now we have a query. So I have a query. We do select name from SQLite master. Now I'm going to back up 1 second. We're working mostly in the console right now, and here is the script scene. So if you wanted to make a script that would run over and over, you would put these commands that you're going to put over here, and we'll kind of build that as we go. So we can do that right now. So we can do import pandas as PD, import SQLite 3 as S3. And then what's cool too, we can go back here and we can make the connection. So now I've just made a script that I can connect to this database at any time, and I'm going to save it here. So now we have the beginning of a script. So I don't have to do this over and over. I already have it in a script ready to go. So I can connect to this database at any time. Okay, so let's go with Pandas here. So now we have a query, which is the select from SQLite master name. Tables, I'm going to create a table where I'm going to put the Pandas data frame. And again, Pandas works on 2 different data structures. Data frame, which is kind of like an Excel worksheet, and a series, which is just a one-dimensional vector. So we're going to do PD because, again, we did Pandas as PD, and we're going to tell it what we want to do. We want to read. Now look at this. We can read a lot of things. We can read clipboards, Feather, HDF, SQL, SAS, anything. A lot of different things we could read. But in this case, we're going to read SQL. So what's cool, if you have a nice interpreter that'll tell you all these things. I'm mostly a PyCharm guy, but I'll use Spider. Also, I think it's easier for this situation. We have read SQL. Now, there's read SQL table or query, but you can just use read SQL. So in this case, we want to put in the SQL and give it a connection. So let's do that. So read SQL. So in this case, we're just going to feed it the query we just did up here. So this is query, select from, and then we're going to use the connection. So we're telling Pandas to read SQL and read this query, which is select from the masterlight, using this connection. And we're going to do it right there. And you can see it's pretty fast. Tables is now, we have 2 tables. So this is a data frame. This is a data frame right here, a simple Pandas data frame. We have purchase orders, and we have a pricing table. All right, so very nice. What do we want to do with this? So, okay, so what we want to do is we want to find purchase orders and the pricing, and find a certain select bit of purchase orders and see if their pricing match the pricing table. So let's do this. Let's say, now let's pull all the purchase orders. So we're going to make it purchase order from, we're going to PD, we're going to read SQL again. And I'm going to write it out here in this case, but we're going to select everything from purchase orders. Now be very careful, because this command basically says select everything, every column, every field that you have from this entire database. All right, now I know that this is a relatively small database. It's only 75 meg or so. I think it's around 200, 300,000 lines. We'll find out in a second. And so we type in our query, and then we do connection. Let's see what that gives us. Okay, so that was pretty quick. That returned the 204,967 lines and 19 columns. So the PO dot head, because we don't want to take a lot of it. It defaults to 5, so 5 So we can see what it looks like. Now, working with Python is a little, it's not as easy as Excel because it's just not right out in front of you. But what you can do is if you take the head, which will give you the purchase order of 5 columns, dot to clipboard, and you can go to your Excel, and you can, of course, open up a new sheet and go like that. And so this will show you what your database kind of looks like. So here, let's do this. We have the commodity, we have commodity description, extension, so everything that we saw in the form. So we have an award date here, so it's looking okay right now. Oh, so here we also have the unit price and the item total amount. So we've got quantity, so this 500 boxes at $7.05 a piece is equal to that, I guess. So we have the entire database in here. So we can see 204,967 rows. So what we can do, if you're in Python, you can look at the columns. And again, if you have questions on what I'm going through here, just ask. So the commodity description, extended description. So these are all the columns that we have. So what we're going to do is we're going to look at award date in this case. So we have a data frame, and we can pull out one of the columns, award date. So let's see what that is. Okay, so the PO award date it's an object, and again, it's 204,000 lines. But what we need is to make this a date. So there's two ways we can do this, actually. So we can go, when we originally pull the data, there's also in Pandas, we can do parse dates equal to date, like that, and we'll pull that. Hold on, I saw your comment there. Parse dates. Okay, so what's the difference between head and column? Seems like it did the same thing. So in this case, if you mean this, like when I went award date, like that. Oh, you know what? I know what you're saying. Okay, so I'm going to go back. So PO goes like that. You can see that it gives you, when Pandas gives you a data frame, it doesn't want to give you all of the data frame, so it kind of gives you a little piece of it. It gives you like the first 5 rows and the last 5 rows. So that's what you do. That's how it shows when you do the data frame in your interpreter here in your console. So, but if I do po.head, it'll give me only the first 5 rows. So if you do head, it'll do only the first 5 rows. Let me see if I can open this up here a little bit. So it only gives 0, 1, 2, 3, 4. Okay. So if I did po dot head 20, it gives you the first 20 lines. Okay, 0 through 19. Now remember, if you're dealing with Python, everything starts in Python with a 0. All indexes, everything usually starts with 0, unless you specifically tell it not to. Just a little hint there. So you can see I've got 20 rows. That's the difference between head and just the regular. And if I do po.columns, it just gives me the column headings. Like, you know, if you go across a table, it'll just give you everything, all of your index, your column index. Okay. So where are we at now? So we've got PO, we've got the award. So I'm going to go po.dtypes. I know if I'm going around and jumping around too much, let me know. Um, so the commodity is an object quantity is a float. That's good because it's a number, unit price, and total amount is a float and a float. And the award date is a date time. So we have date time. Okay, good. So award date is now date time. This means we can slice on any of these, but the date time is here. So what have we done so far? So we've connected to a database. We've pulled all of the purchase order data. Okay. So we really don't want the purchase order data. We don't want all of it because let's say we just want to check out 2016. So do you want me to do both the SQL way of doing that and the Pandas way, or just the Pandas way? DBZ, let me know. But I'm going to do the Pandas way first. PO. So I'm taking the purchase order. Now this is an idiom for Pandas. So I'm going to take purchase order, the purchase orders, where the purchase order dot award date is greater than or equal to, and I'm going to give it a date. I'm going to do 2016 -01 -01. I'm going to do Pandas because honestly, you can look up SQL at another time. So PO award date. So what I'm doing here is I'm taking the purchase order data and I'm going to slice it. So this is how you slice it. I'm going to slice it on the award date. So purchase order, slice it based on the award date where it's greater than 2016-01-01, greater than or equal to. So if I go like this, it gives me this. So I've sliced it. So now out of that 200,000 rows, there are only 9,256 rows where it's in 2016. So what I'm going to do, what I can do is this. I'm going to do purchase orders for 2016 is equal to, and I'm going to do it again, purchase order, where purchase order dot award date is greater than or equal to 2016 -01 -01. Now there's some tricks I could give too, but let's just do that. Actually, you know what I'm going to do? I'm going to do dot copy because taking a slice of a data frame, you can actually go back to the original data frame. It's a little complicated, but it's good to do copy when you're taking a slice that you're going to work with. So now PO.2016 is, again, 9,256 rows. So we have 9,256 purchase orders for 2016. Okay. So we can take one of these. So let's talk about slicing even more here. So now we have purchase order 2016. In fact, I'm going to delete the purchase order one. So I just got rid of purchase order. And now we just got purchase order 2016. Makes it easier. So purchase order 2016 let's do this. Purchase order 2016. We're going to take one of the rows. We're going to take row 4 here on the index because this is the index. Loc 4, and that gives us the single amount here, the single order. So we have commodity, so that's our commodity name, it gives us a commodity description, amount, and everything. So in this case, there was no unit price, there was just strictly something like that. Okay, so what we'll do is we're going to fill out our little form here so far of what we got. So we'll go back to our history. So what we want to do is we've got a connection, and what we'll do is we'll take the purchase order data and we'll go back here and we'll put in the purchase order that we selected, and then what we'll do is we'll take the think we had to do this. So actually this for the PO. We wanted to parse the dates. So we'll put that here. I know it's hard to see. I'm sorry, everyone. Okay. So now we're taking from the console what we've done, and we're putting it into a script that can be replayed over and over. Okay, so award date, and then what we'll do is we'll do PO 2016 is equal to this. So now we are creating the 2016. We're going to delete the PO, and then we're going to so now we have the purchase orders for 2016. Okay, I'm going to go back to the console here. Okay, so now what we need to do is we need to iterate over these and find out a pricing. So let's get the pricing data. Again, what we'll do is we'll do pricing. So this will be the contracted pricing from the country. So we're going to pd.read SQL. And actually, you know what I'm going to do? I'm going to do pricing query. Select everything from pricing table. There we go. And we'll put that over here too. The price query up here. I'll organize that a little better in a little bit. So we'll grab the pricing tables is equal to pandas at read SQL again. And what we'll do is the price query here, and from our connection. And what we want to do is parse dates equal to, in this case, it's going to be price date. That way we'll bring in our pricing with a date format. So now we have pricing. Now we have all our contract pricing. So, and when that date took effect. So we'll be able to see if we do pricing here. We can see that we have the commodity description, the unit of measurement, the unit price, and the price date. So the price date is when it took effect. So we can have multiple price changes for a single commodity. So like this one right here, the asphalt concrete changed in 2014, and then it went to $49.60 in 2016. Two-way radio had a change in price. So now we have a pricing table. So what we have to do is we have to bounce up our purchase orders against our pricing table. So let's do that. Okay, so now we need to get into this a little bit. So I'm gonna jump ahead here. So what we need is we need to iterate through this pricing in the purchase orders and get the date that the purchase order was awarded and the purchase unit price, and then see if the pricing data over here matches the same, is the same, or what is the difference. So what we can do is this. And what we can do is this. So we'll start out with a for loop. We're going to iterate through the, and again, this is the Python for loop. So for x in PO 2016 dot index. So what I'm doing is we're going to iterate, in this case, through the index of the PO 2016. So that would be this. So if we go PO 2016, that'll be this. We'll be going through 4, 9, 12, 17, whatever the index is. Now this, you can iterate almost over anything. You could iterate over commodity levels. It kind of depends on what you need, but for in this case, we have to go by unique level, and I know that the index in this case is unique. So again, most indexes have, most databases have a primary key. So, and a primary key is usually not repetitive and unique for every record. So in this case, let's do a print X. So the first thing we have for X, PO is index. So to make this short, I'm just going to index this little, I'm going to take the first 10 records. So I'm going to run this right here, and I can show you what it's going to do. So what this did is it went through every X, for every X in PO index, or at least the first 10, print X. So it gave me the first index numbers, 4, 9, 12. Okay, so it shows that we're iterating through each one of them, each one of the records. So in this case, we need to start getting the data out of that record. So let's try this. So let's get the amount charged first for each record. Or actually, let's do the date. So the PO date. PO date is equal to, and again, let's go back here and show. So to PO 2016, and we're gonna, as we talked about before, we're gonna slice it. I'm gonna slice this one order. So now we can see what this one order looks like. You can see that it has commodity, it has the unit price right here, and the award date. So we want to get those are the two things for this record that we want to get first. So we're going to grab the award date. So for this record. So we're going to do the same structure here, except we're going to feed, instead of 4, we're going to give it the X. So PO underscore 2016. So we're taking our data frame, and we're going to take the record loc X in this case, which will be X, which will be 4 because that's the first one in our little sample here. So let's run that. Let's see what we do, what we have here. And what we're going to do is we're going to print PO date. Okay, so what we did was we took the order, each one of the orders. So it's printing out each one of the orders in total. So what we need to do is we only need the award date in this case. So let's run this again. And I'm kind of trying to do this over and over so that you can kind of see the repetition. So now we can see that we are printing out the number and the index number and the PO date. So we have a PO date. So now we can get rid of this. Now the next thing we're going to need is the PO price. Is equal to, from the PO, we're going to take 2016. We're going to take the unit price. Unit price of loc X. So that's going to give us the price. And again, I'm going to try it here. So we'll do a print PO price, and we'll run it. Okay, so it looks like we're working here. So it has 4, and it's giving me the price, print out the unit price. So what we'll do now is, what we need is the pricing, the contract pricing for this amount. So in this case, we have the pricing. So now we're going to use the pricing pricing data frame. So you can see that the pricing data frame has a commodity as well. So we can have a pricing. So what we also have to grab from here is the pricing. So I kind of the commodity. So I'm going to put that right now. Commodity is equal to PO underscore 2016 dot commodity dot look X. So now we're going to use that commodity label to grab the commodity from the pricing here, pricing table. So we'll do um, pricing dot pricing where pricing dot commodity is equivalent to, and we'll do whatever X is, whatever the commodity is going to be. So let's see what that does. Commodity. Oh, I didn't run this. I'm going to run this right now. All right, so that'll just give me a value for a commodity. So you can see that the last one that we took is this commodity right here. So we have a price date. We have a single record for pricing for this commodity. So in this case, what we want to do is we want to do the price charged, the contract price is equal to PO, nope, pricing dot unit price dot unit price unit price. Yeah, okay. Let's see what that does. I'm gonna run that right now. Contract where unit price where pricing. Should have really thought about this before I put it together. Pricing dot commodity is equivalent to commodity. Okay. So what we're saying here, this is a little complicated, but we're taking the pricing data table, and we're going to look for the unit price where the commodity is equivalent to the commodity that we're looking up. Okay. So what we'll do here is we'll do print contract price. Okay. Run it. Okay. So now you can see it's taking the full price right here, the full record price. So we want to actually pull that down a little bit. And give iLoad 0, and that should give us just the value of the price. Now the difference between iLoc and loc is one's the label. One is the label, and the other one is the. Let's try that. Let's see if values works. Okay, it's giving us a value, giving us the array value. Okay. Yeah, I don't think that's going to work because that is the pricing. What I'm trying to do is I'm trying to get the price out of the record. Okay, yeah, because that's a hashing price. Anyway, let's go over here. Okay, so we have the unit price again. Yeah, let's do this word. Let's do the contract record. Let's change it here, and what we'll do is we'll go the contract price is equal to pricing contract record price unit price. Okay, and what we'll do is we'll take PO price, purchase order price, minus the contract price. Print that. So there we go. We can see that the unit price, the difference between the two. Okay. What we'll do now is we're going to put what we're going to do now is we're going to add columns to the purchase order. So we're going to do the purchase order 2016, and we're going to put a new column, and we'll do the contract price. It's equal to none. And we're going to do the PO 2016, and we're going to do percent variance is equal to none right now. So now when we do this, we can see that we've added two more columns to the pricing data, to the purchase order data. So if we go here, and right now they are filled with none, so contract price and pricing variance. So what we're going to do is we're going to use this right here, and we're going to fill in the contract price and the pricing variance for the purchase orders, for each one of the purchase orders. Okay, so what we'll do is now that we have the pricing record, what we'll do is, if I can move this over, it's so slow, is what we'll do is we'll put, so now the purchase order, 2016, dot, and what do we call it? Contract price is equal to contract price. So we'll do dot look x, which is the internet, and then the column. Again, we'll go back to the slicing, and we'll see what happens. What happens here? Let's run this. We'll do this. Run this. Hold on a second. Oh, we're getting an error. So what we're going to do is I'm going to throw in a try. So we'll do a try. So the way you can handle errors is by throwing in a try. In this case, it's we'll do a little sloppy here, but it will make it work. Okay, and then what we'll do is we'll and accepting. So this is a try accept. What we'll do is I'll take this from my previous thing. In 2016. And error. So what we're going to do here is if the data is messy, like it is in this case, we're going to go through, and if there is an error, we're going to put in error right now. So we'll see what we can do here. All right, so let's do this, and PO16. So PO16. Let's do this. Let's see, PO 2016. Columns. Let's see what the name of this was. Oh, we only have the contract price. Okay, so that makes it easy. We'll get rid of this here. That. And get rid of this and this because we don't need the extra amount. And we'll go right here. Run it. So now it went through each one of ours. So let's see what the PO 2016 data looks like. And we had some errors in the contract price. All right, I gotta fix this thing. Here we go. So let's do this. X equals 4. Okay, let's do something. So let's do commodity. So let's look at what commodity is. Commodity is that. Okay, let's do this. PO date. PO date. All right, so there's a timestamp of March 31st. Let's do this one. PO price. PO price is 0 in this case. Let's get the contract price. Contract record is this. Contract record is, okay, so it's a single record. So let's do contract record. Contract underscore record dot unit price in this case is 00 dot iLook 0. Unit price dot iLook 0. Now let's see what we get in this case. Okay, 2016. Bring it up. Bring it over here. And now we are populating the contract price with the amount. And wherever we get an error here, we're giving it an error. Okay. So one thing we want to do is we also want to create a variance analysis. So we'll do PO 2016 % var equal to none in this case again. So we want to create a variance table. So PO 2016 dot loc, and again we're using the index and we're doing the percent variance equal to the in this case PO price divided by the contract price minus 1. And if we run this, let's see if this works. Okay, so here we go. So in this case, now if we open up the data frame, we have the contract price as well as the percent variance. Again, the contract price is 0 here, it's 162, percent variance is 0 because 162 and 162, which is right there, is exactly the same in this case for us. So in this case we had an error. So there was nothing here. Now we have to figure out why this error occurred. Here we have 1157. So we'll see what the unit price is here. The unit price here is 3650. So a big difference. We have to figure that out. Here we have a negative price difference, and this is we're way overpriced right here. So there you have it. You have a script which can take data in, load it, and analyze it as far as providing a variance analysis for pricing. Now, one of the things that this can do as well is if we take the pricing data, and maybe I'll leave this for the next time, but one of the things that we did talk about was this right here. This had multiple price changes. So what we'd have to do for next time, possibly if I ever do this again, will be to create the script so that it looks into the amount and finds the correct PO price based on the PO date and picks the correct record here that you need to analyze the data. And that's it. So let's see. What if I do this? I'll do this. Take that. Let's see what that looks like. Again, if you have a data frame, so we've got pricing, where pricing dot commodity is equivalent to that. So we can see there's 3 pricing dates for this single commodity. And because it had 3 separate pricing dates, we couldn't just do a merge with this database. So that's one thing that's great about Pandas and Python is you can deal with a lot more complex setups. But again, we'll probably leave that for next time. So just review, way back here, we went through and connected to a database. We pulled data out of the database using Pandas. We sliced and diced the data, and we used logic to compare data and spit out an analysis. And that's it for right now. Thank you for watching. I definitely appreciate it. Have a good night.